Hi guys, so this problem appeared in 2017 for 1 marks, and this problem is based on the single phase rectifier. And if you observe the circuit, so this circuit is based on symmetric configuration of single phase rectifier. So let us see what the problem is saying. The problem is saying that this rectifier is fed with a single phase transformer with the voltage of 230 volt, and it is being a step down with the turns ratio of 10 is to 1. So we all know that V2 by V1 V2 by V1 is equal to N2 by N1. This is the transformation ratio that can be applied. So we can assume the rectifier is fed with 23 volt 50 hertz, right? So this much part was straightforward. They just wanted to check out your basic concepts of transformation ratio. After that, this problem is based on single phase rectifier only. Now, it is saying that assume that all devices are ideal and the firing angles of the thyristors T1 and T2 are 90 degree and 270 degree. So alpha is given, alpha 1 is 90 degree, alpha 2 270 degree. Now we have to calculate the RMS value of current through diode D3. So we have to current this, you have to calculate the RMS current of ID3. So to solve this, first of all, we should calculate the duration of D3 for which it is conducting, and we have to know the current that is flowing through the load, that is I naught. So this both current we have to calculate. For that purpose, I have drawn the waveform. So you can see this would be the waveform of V in. If you can see, so this is the waveform of V in here. Uh, its maximum value would be 23 into root 2 because the 230 volt or 23 volt would be the RMS voltage. So 23 into root 2 would be the maximum voltage of input to the rectifier, and the durations are given here. Now the voltage V naught, how it will vary. So see the V naught waveform, since the alpha 1 means this T1 thyristor is getting triggered at 90 degree. So for 0 to 180 degree, uh, this voltage is positive. So let us draw. So from 0 to 180, this would be like that. So this T1 is forward blocking mode because alpha is means firing angle is 90 degrees. So from 0 to 90 degree or 0 to 90 degree, T1 in forward blocking mode and D2 in forward conduction mode. And since T1 is not conducting till 90 degrees, so D2 would not have any other path to close the circuit. So that's why after 90, when T1 and D2 both will be on forward conduction mode, like from 90 degree to 180 degree, T1, T2 conduct. So when T1 and D2 both will be conducting, then output voltage, this output voltage, this would follow the input. So input is this one, sinusoidal one. So output would follow from pi by 2 to pi. At pi, at pi, since T1 would conduct till 180 degree. After 180 degrees, since it is a resistive load, so T1 has to be turned off. Means at 180 degree, D1 would get turned on 180 degree, and T2 should get turned on. Then it has to supply the load. But the catch here is the alpha for T2 would be 270 degree. So here D1 and T1 should freewheel the current. Since we have the diode D3, so it will freewheel the current. But there is another catch that it is resistive load. So for resistive load, after pi, it would not be in conduction mode, right? So for that purpose, D, D3 would not conduct. So D3 would not conduct. Again, from pi to 2 pi, from pi to 270 degree, this T2 and D1 should conduct, but T2 is turned off, or we can say it is in forward blocking mode till 270 degree. So T2 would not conduct, so D1 is only turned on, so it will not provide any current or voltage to the resistor load, and hence uh, no current will be there in D3 as well. If it would have been an inductive load, then D3 could have been conducted till the conduction goes on. But since it is resistive load, so D3 would not conduct here. And again at 270 degree, D2 would turn on and D1 would be on already. So here T1 and D2 are there, and D3 is not conducting. Here T2 and D1 is there. Again, D3 would not conduct. So D3 is not conducting because of the resistive load. If you try to calculate V naught average, you can calculate uh, since the conduction is happening between pi by 2 to pi, so 1 by pi, and average of Vm sin omega t d omega t, and you will get V naught of 10.35, and I naught average, you will get V naught average by R. So, but D3 is not conducting due to resistive load. Hence, ID3 would be 0. Thank you.